Hi everybody and welcome to Oxford Street. Now in a typical day, something like 500,000 people will walk down this street, and at Christmas it can be 10 times that. There's so many people here, you can't walk against them, you have to go with the flow. That's an awful lot of people walking by. When you think about what walking actually is, it's more controlled falling. You basically pick up your foot, lean forward and stick that out there to stop yourself falling flat on your face. So if you think about walking that way as dropping a weight from a height, in effect what you've got is a gravity generator. And of course this is not something that have escaped people. And in 2017, PaveGen stuck a pavement here to collect all of that energy. It's gone now. So although the Bird Street project is gone, the company installed another of their pavements right here at Finsbury Square Avenue. And the company, well, they're quite shy about talking about their technology, what's behind it. And all they really say is that it's an electromechanical device. There are three main ways that footfall harvesting is being implemented, and that's piezoelectric, electrostatic, and electromechanical. The electromechanical is pretty much what we've used for generation for ages. It is essentially a coil and a magnet that are moving. If you look closely at the PaveGen device, then it's not much more than a ruggedized internals of a speaker. It's a circular coil, a circular magnet, a rubber cap to stop it all wearing out, and it bounces up and down by 5 millimeters as you tread on the pavement, which is made out of recycled tires. But what sets them apart is that they're actually installing a device, whereas lots of the others are just sitting on lab benches. Of course, energy, how we get it, how we use it, and the impact it has on our environment is a huge concern for us. Of course, everything new needs time to mature. New technologies need time to develop. And when it comes to ideas about energy harvesting, of course, they need time and they're at the early stage, but we need solutions as well. Because the big argument against energy harvesting is that there isn't that much energy. Now, I always think of arguments like that as a little bit spurious, because nothing when it starts as a new technology is any good. And if you applied that argument to electric motors, well, we just wouldn't have them. So bearing all that in mind, I decided to give it a go doing an electromechanical energy harvester. And I came up with this. Now I've drawn this in Tinkercad, but have made the files available in Thingiverse. If you want to copy this and give it a go and change it, then by all means do. And the main part is this part here. This is a big old gear cog, which is modulus 1.5. And right in the centre, integral to the cog, is a spring. So if I do that, it will oscillate. So I'm figuring that if this has the impact of something like a footfall maybe, or like a wind blowing it, when it stops it will continue to oscillate and therefore act as its own store of energy and continue to generate. And of course we need something to put that in, so we have these flat plates. Now these flat plates have these nodules on them, and on there I've wound a serpentine coil, so it goes in and out and across the top to make a serpentine coil. There are two of those, and there are these three pins. The three pins accept this, so we can put that on there with the magnets obviously in line with the coil. And now if I oscillate that, we have a magnet oscillating around a coil. It's going to be a generator, but of course we have the other side. Now if we were just to hit this, it would bounce up and down and a lot of the force would be gone. So we have two gears that go here and here, and they stop it from going up and down. It can only go backwards and forwards courtesy of those two gears, because those two gears are also acting as a gear ratio, so there'll be a lot of torque on here, in fact much more torque than there is on here. Could use that in a different design. Now at the top of this you'll see there's a 4mm hole, and that's so that I can do something like this. This is a bit of 4mm rod, and that could go in there, take away to the top, and when the wind blows of course it's going to oscillate it. But equally we could put a bar on here, and if we tread on a panel again it will oscillate it, because I want this to be adaptable, and that's why I've arranged it that way. Now we have the other plate done exactly the same way, and that plate goes on there, and then between the two there's a foot plate which is there, and that goes on there. So let's glue all that together. So there's my little energy harvester, and all we're going to do is flick it backwards and forwards and see what we get out of it. And I've got it attached here to this voltmeter. Okay, we got a volt out of it, which is quite astounding for what it is if you think about it. Now, this isn't a finished project. It's meant to be the heart of other projects. It's a generation system that is adaptable to other things. Like I mentioned before, if we put a rod in there and tie it to a tree or a bush, or we put a flag on the top, of course the wind is going to blow it and it's going to continue to oscillate. If we put a lever on it into a pavement, exactly the same thing. It'll press there and oscillate. If we put a rack on it right there and attach it to a shoe, it would become a shoe generator. So there's a whole lot of things you could do with that, which is why I designed it that way. I think it wins because it stores the energy between one impact and another in this central spring. So when you take a step and it pushes it down, and you're taking the next step, it will continue to oscillate because extra energy from the step is being stored in the spring, and that's being released as you're taking the next step. So I think it's likely to be reasonably efficient, and it's certainly adaptable. So I'm hoping that people will take this and work with it and come up with other things that they could do with it, whether it's a wind generator or a footfall harvester or whatever it is that folks come up with. I'd be absolutely fascinated to see. Now, the wire here is 0.2 millimeters diameter. It's only 0.2 millimeters diameter because that's the wire I have. If I had thinner wire, I'd have put thinner wire on, but I didn't. I had that, and that's what I put on, and it worked really quite nicely. So remember, the files for this are in Thingiverse. The link is in the description. I hope you find it interesting and useful, and I'd love to see what you come up with if you do adaptations of it. Thank you very much for watching, and please do remember to like and subscribe.